Hi everybody, and welcome back to my channel Numbers with Nora. For this specific video, we're going to be doing Algebra 2, Unit 1, Algebraic Essential Review. This is actually going to be on Lesson 4, and we're just going to go over some basic exponent properties. Again, this is just review of Algebra 1 before we really get into some hardcore Algebra 2 stuff. All right, and the book I'm going to be using is Common Core Algebra 2. I will put in the description the link to this free online book. And then also I found this really cool Microsoft Math solver. So if you guys want to just sit there and check your answers whenever you're doing any kind of algebraic equations, you can go ahead and click on here and it will take you to the link to the Microsoft Math solver calculator. I'll also put that in the description. All right, so let's go ahead and get started. So like I said, we're going to go over the exponent rules that we saw in Algebra 1. So just kind of a quick review. And then also we're going to sit there and start getting our feet wet with factoring again, because in Algebra 2, we're going to be doing tons and tons of factoring. So with exercise 1, it wants us to follow the 4 steps that are given to find the product of the monomials, -2 x to the 5th and 4x to the 2nd. Monomials are just one-term expressions in math, okay? All right, so let's go ahead and start with this. So we're just going to sit there and say or state the property that we're doing. We did this in lesson 3 and in lesson 2, I believe, in my other videos. All right, so first this step right here, if you see, they kind of distribute out that -2 from here. So we're going to go ahead and put distributing. Yeah, we can say the distributed because we pulled out the -2. Distributive property. Actually, I don't want to use distributive property. This is more like associative, because we're regrouping our multiplication. So I feel better with that, associative. Okay. And then for the next one right here, if we notice what they do next, we're switching our x to the 5th and our 4, right? And we can do that only with addition and multiplication. And so that one's going to be commutative. Oops, why is this popping up? Sorry. Property. Commutative property, okay, because we switched that 4 and the x to the 5th. And then next right here, it looks like we're doing our grouping again, okay? So I guess we can say associative again. So we're associating property. All right, and then we sit there and write to -8 x to the 7th power. Right, so we did that for A. For B, explain why the final exponent on the variable x is 7. So remember, with our exponent rules, this is another property. For here, when I sit there and multiply two variables that are like base, what I got to do with their exponents is I'm going to add them. So that would really look like x, because they're like bases, 5 plus 2 as I add my exponents, right? And that's another property of exponents. When I have two like bases and I multiply them, I add their exponents. So 5 plus 2, that's supposed to be 2, is going to give me 7. All right, so that explains B. And let's go ahead and go down to exercise 2. They want us to find the product of each of the following monomials, right? So this one, we're just going to sit there and be grouping together, right? So let's work out some of these. How I like to rewrite these is I like to write them as 5 times 3. I sit there and like to get my constants together. 5 times 3. And then I like to get my variables together. But remember, since I'll show you this step first, times x to the 6th. All right. And then remember, since I'm sitting there and I'm multiplying like bases, I add my exponents. So 5 times 3, 5, 10, 15. And then I add my exponents. 6 plus 2, 6, 7. Okay, that's 7. Okay. Boop. So that's good for that one. Or 6, 7, 8. My apologies. 8. I've been doing math all day long, so If I do something wrong, don't be scared to check me. All right, cool. Now let's look at B. Again, I sit there and get my constants together. -2 times -6. Okay. And then again, I have x. Remember, there's always, if there's no annotation of one, there's always like a 1 up there for that exponent. If they don't show that there's a number up there, there's always that 1, okay? I like to just write it there so we remember. It's always to the first power if there's an x. All right, so -2 times -6, those are going to cancel out. I get positive 12. Again, I add my exponents because I have like bases, and this is going to be 5. Okay. That's my answer for there. All right, C, I do the same thing. This time I have fractions. That's okay because multiplying fractions together is easy. 6. And I can put that over 1 if I really want to see that. All right. And then again, I have my like bases. I have x to the 4th. And then I have x to the 10th. So I'm just going to sit there and add those exponents when I get a chance. When I sit there and simplify this down, 6 times 3, that's 3, 6, 9, 12, 15, 18 over 2. 18 over 2 is 9. And then x to 14. Okay. Because 10 plus 4. That's the answer for that one. Now we have this one. Now don't get tricked. Notice I don't have like bases here, so I'm not going to add these exponents. This is kind of like distributing property. I kind of like to think of it when I have an exponent that's like sitting up against a parenthesis. I have to sit there and treat that as it has to hit each and every term. So it's going to be like a distributive property. Okay, what I mean by that, that 2 exponent goes to the 4, so that's 4 squared, and then times x to the 3rd. And remember, I'm not adding these, I'm multiplying them, okay? So now I'm going to get 16, and then x to the 6. Okay. And that's like more of the distributive property. Okay. Cool. So now let's look at exercise 3. This one, they want us to find each of the following products. Products is the answer to a multiplication problem, which involve monomials of multiple variables. Clarify, consider what you are doing before applying patterns. Okay, let me make sure this hasn't shut me out yet. No. All right, so for this one, again, I just want to group together my like terms. That's how I like to do it. All these are being multiplied, so let's do it like we did before up top. So 4 times 5, okay. And then I have my x's together, x to the 3rd times x. Remember, there's always that imaginary 1 up there if it's just a solo variable. And then y squared times y to the 5th. Hold on just a second. Sorry, it always tries to kick me out. There we go. To the 5th. Okay. And now I start simplifying this. So I have 4 times 5, which is 20. And then my x is like bases. I add my exponents. 3 plus 1, that's going to give me 4. Again, like bases, I add my exponents. 5 plus 2, that's going to give me 7. Okay. And that's my answer. Okay. Let's go ahead and look at B again, just to emphasize. I'm going to write all my like terms that I'm multiplying together. So I'm writing my constants that I'm multiplying together. I'm writing my x bases that are like bases together. Those ones, x squared. And then for my y bases, y to the 3rd times y to the 6th. And now let's add those exponents and simplify everything down. Negative times a negative is going to be a positive. So I'm going to get 2 times 4, which is 8. I add those exponents together. 7 plus 2, 7, 8, 9. And then my y, same thing. I add those 6, 7, 8, 9. Okay. I can go a step further. All right. Because I noticed that both of these exponents are 9. I can rewrite this. If I want to be fancy with it, x and y to the 9th power. Okay. That's just if you want to, if your teacher really wants you to sit there and do it. Okay. But both of these are the same thing. Okay. All right. And then our last one, C. Let's do this one. So I have 1/2 times 5/2. And then my x's, I have x. Remember, this is a solo x, so there's always going to be that 1 up top, and then x squared. And then y, there's always going to be that 1 up top, and then y to the 5th. Okay. Let's go ahead and keep on simplifying down. When I multiply fractions, I just multiply left to right, left to right. 5 times 1 is 5. 2 times 2 is 4. That's 5/4. I cannot simplify that down, so I'll leave it like that. X's, I add the 1 and the 2. That's going to be 3. My y's, I add the 1 and the 5. That's going to be 6. Okay, and I can just leave it as so. Right. And that is that. And again, if you want to go ahead and check my answers, like I said, I'll leave in the description this really cool Microsoft Math Solver. It's really good when you're trying to check your answers for your homework, but also I'm pretty sure your teacher's going to ask you to show each and every step of your work. So she makes sure you're just not plugging in the answer to your calculator. All right, so for this one, fill in the missing blank in each of the following questions involving a product such that the equation is then an identity. Okay, an identity is when both sides of the equation are matching. All right, so let's look at this one. So basically, I want to look at what I can multiply 2x squared by, so I get 6x to the 5th. The easy way to do this, how I like to do it, is you divide this by what you have here. So if I divide this, okay, then I'm going to get what belongs in that missing thing. 6 divided by 2, that's going to be 3. And this is another property. When I'm dividing variables that have like bases, I sit there and subtract their exponents. So that looks like this because I'm sitting there subtracting, or I'm sitting there dividing these. Oops, that's not what I wanted to write. Sorry. Since I'm dividing like bases, this turns into x, my same base, 5 minus 2. I'm subtracting my exponents here, okay? 5 minus 2, that's going to be 3, so x to the 3rd. And if I sat there and multiplied this out, just like we were doing on the top, I should get x to the 5th, which I would, okay? All right, so that's like an easy way to think about it. You just divide it by what you have over there in those parentheses, okay? And you'll get what's inside. 4 divided by 12. Oops, sorry. 4 divided by 12, that's going to be 3. And again, 8 minus 3, that's going to give me what that is. 8 minus 3, that's going to give me 5. Okay, so that's in there. Again, I divide this by what I have in there. XY cubed. Remember, there's always that imaginary 1 right there. So I have 20 divided by -2. That's going to give me -10. For my x's, 2 minus 1, that's just going to give me x. 4 minus 3, that's just going to give me y. And that's what I get inside, okay? Let's go ahead and look at exercise 5 using the distributive property to multiply the following monomials and polynomials. So let's go ahead and do these. I'm actually, for sake of time, I'm just going to do A and E. If you want to see any other ones, let me know. Okay, so this basically what we're doing is we're going to like expand them. Okay, Okay, so let's look at this one. So we're just using the distributive property. That means that 2x has to hit each and every term inside of my parentheses. So for this one, I get 10x squared, because those are like bases, and we add our exponents, and there's one right there. And then 2x times 3, that's just going to give me 6x. Okay, x. And that's my expanded version. And you can always check your answer by sitting there and distributing out or factoring out a 2x, and you should get exactly what you got from here, right? This is the compressed version. This is the expanded version. We'll sit there and go over more factoring later on. All right, so let's go ahead and skip to E, because this is one of the harder ones. That means this outside expression has to hit every term with inside my parentheses. So let's go ahead and break it down. 3 times 2, 2, 4, 6. That's going to give me 6. X squared times x squared. That's going to give me x to the 4th. Y to the 4th times y. That's going to give me y to the 5th. Okay. And then we go on and hit the next one. I have 3 x to the 3rd. 4 plus 2, 4, 5, 6. And then minus 6, 6, 9, 12. X squared just comes along for the ride because there's no other x squared there. And y, 4, 5, 6, 7. Oh no, sorry. X squared, 4, 5, 6, 7. Yeah, 7. Okay. And that should be the answer for E. And basically, we're just expanding this out. Okay. And that's the using distributing. If you want to see B, C, or D, sit there and hit me up, leave a comment, and I'll do those ones. Okay. So for 6, similar to exercise number 4, fill in the missing portion of each. So the equation is an identity. I'm just going to do 2 of these. Let's do A and D again. All right. So for this one, again, I can just divide each of these by 4x, and that's going to help me out. Okay. Divide them by 4x. See what I get. Okay. So that's going to be 8 divided by 4. That's 2. 2, and there's always an imaginary 1. That's just x. Okay. Then again, minus. And then 12 divided by 4. That's 3. And then x1 minus x1. Those just cancel out. So that's just going to be a 3. Okay. And I know I'm correct because if I sit there and distribute this back through, I'm going to get this right here. 8x squared minus 12x. Okay. Good. If you have any questions on these, again, let me know. So this one's like a little bit trickier, but again, even if we did sit there and use that division thing, that can help us out too. So I sit there and divide all of this by what I have there. And then divide this by that, by what I'm multiplying it by. I notice that these just cross out. They cancel out, right? So what I'm going to have in here is just 4x squared. And then minus 9. Okay. And this comes back to another thing that we're going to go over in factoring as well. Okay, like I said, in Algebra 2, there's going to be a ton of factoring. All right. So if you have any more questions on these sections or anything like that, leave in the comments which ones you need help on. I'll show you step by step how to get there and the answers to them. Yeah. So thanks for tuning in. And if you have any homework questions or would like further tutoring, please subscribe or leave a message in the comments. Thank you, guys.